Hey friends, it's October. It's the 2nd of October, 2024, and we are here as we usually are on Wednesdays, starting at 14:30 for Plutus PBL live coding with Gimbalabs and friends. We just had some nice time to catch up and talk about a few things that everybody's working on. We usually have a little chance to talk about what we're doing before starting the recording. But now that we are recording, the goal is to look at a brand new module in Plutus PBL together. I'm going to share my screen over here. And what you will see on my screen is that Plutus PBL is live on Andamio, so we're going to view that. Ooh, the Game Changer team just pushed up a public course. That's kind of exciting. But we're going to look in here, Plutus project-based learning. And we've been rolling out modules. We fell a little bit behind in the 200 modules because there was so much going on this summer. But we're finally to the point where the last few modules, 204 and 205, are going live. 204 went live just yesterday. Actually, it has today's date on here, October 2nd. And Validator Essentials will go live at the end of this week. We'll probably focus on this one at live coding next week. So I'd like to look at querying the blockchain. We have 4 learning targets here. We'd like to introduce you to how to make a blockchain query with BlockFrost. We'd like to repeat learning how to make blockchain queries with Maestro. And then once we take an initial look at both of those, I'd like to show you how Mesh makes it really easy to work with both of these and other providers by showing you how Mesh providers work. And then we're going to take a quick look at what an indexer does. We're not going to go too deep in this course into building our own indexers, but I'd like to just show you why indexers exist. And then I'll point you to some other content that can help you go a little deeper into this. So those are the learning targets. And the introduction here says, well, we've already learned a lot about transactions. If I look at a review of the course, right, people got started and they minted a PPBL 2024 token. That requires a transaction. And then after you minted your token, you used it in the live demo at Plutus PBL. And let's look at this for just a second, actually. It's not opening a new tab. Oh, there it is. Yes, it is. And let's actually go over to, oh, now Zoom is doing that thing. I can't type a new address into my address bar when I'm sharing screen. If anybody knows how to fix that on Zoom, on Ubuntu, I'm open to feedback. All right. So right here at the Plutus PBL course, I can navigate to the live examples, which of course I can't click on that link while sharing my screen. So I'm going to click on it and then let's look again. One more time. Let's try it. Okay. So this is the live examples page at plutuspbl.io. And once people, what browser am I in? I can't see that either. I'm really sorry to keep sharing and unsharing. Just navigating a bug of screen sharing on Zoom, I guess. Let's try that again. Try it this way. All right. So here on the Plutus PBL live examples, if I connect a pre-prod wallet, First of all, I can see whether or not I have the token. And in this particular wallet, I do. But then for learning target 100.5, remember, and this learning target says I can interact with a Cardano application. That's what people are invited to do right here. And this is a very basic application. All it does is it says, hey, if you have the PPBL 2024 token, we will allow you to withdraw 1 million scaffold tokens from this faucet. It's not a very complicated app, but we do use it in future lessons to help people go a little deeper. Why am I showing this to you right now? Because at the end of the day, this requires a transaction. When you build a dapp on Cardano, usually your goal is going to be to facilitate transactions on chain, because transactions are how we update the state of the ledger. Without transactions, all we're doing is we're looking at data. But here's the thing. For any application, people aren't going to build transactions without having a reason. So your app has to provide a user experience with enough information so that people will start building transactions in your app, doing the things that you're trying to facilitate. You're going to have to present information that's currently on the blockchain in order to facilitate this. And there's a silly example right here, right? This shows you how many tokens are still locked at the faucet address. But that's just a basic example of what I mean by blockchain information. And this is why we have queries. It enables us to get the information we need so that we can place it in our UI and build a viable app. Additionally, looking into the future, when you do construct a transaction, it's often the case that you're going to have to get information from somewhere on the blockchain. Sometimes that information comes from the wallet that I've connected. Okay, so my wallet with this pre-prod address has a little less than 7,000 test ADA in it, and it has a PPBL 2024 token. And the reason this application knows that is because my wallet is connected. Wallets already have a lot of blockchain query capabilities built in. But sometimes to build a transaction, I'm going to have to know things about addresses that are different from my wallet address. For example, right here, what's the UTXO at the faucet address? It's not in my wallet, so I have to get that information from somewhere else. And without that information, I won't be able to build a successful transaction right here. So I'm saying all of this because this is why querying the blockchain is so important. To build an application, you will definitely need to query the blockchain at some point. And even though we've looked at transactions, smart contracts, validators in a bunch of different ways, we haven't spent that much time on this concept yet. So let's jump in. In the first lesson, I want to show you how to use BlockFrost to make a basic blockchain query. And to build this lesson, let's go back to what we were just looking at in lesson 100.4. In lesson 100.4, like we just saw, people had the chance to mint a PPBL 2024 token. And actually, there's already a list of some of these tokens right here. But let me change examples. Down at the bottom, right? Once again, I'm at Plutus PBL live examples. And at the bottom of this page, there are examples for several different modules in the course. And I'd like to look at the examples for module 204. The first example that goes with this lesson, 204.1, is the block frost example. And there's a button right here. And this is very simple. When I press this button, a query is going to happen. Let's just start by looking at the results. Watch this. I press the button, a query happens, and oh my gosh, here's a list of all of the PPBL 2024 tokens that have been minted. Cool. Now, hopefully you notice something fishy going on. It looks like there are 2 tokens for every name. One of them starts with the number 100 and one of them starts with 222. And we're going to talk more about that in the very next lesson. But for now, right, we're going to talk about that in the next lesson. For now, let's just take a look at the example code. There's a few different ways to access the example code for this demo. One way is right here on the page. Right? You can just scroll through the lesson and take a look at the code, but this code is also available in this open GitHub repo, the PPBL 2024 repo, which is the source code for this website, plutuspbl.io. Has an example right here. It's in the source directory, in the components directory, where we have this queries subfolder. And then inside of queries, we have some examples of block frost queries and of Maestro queries. And for now, we're starting with this block frost query. And the code that's on my screen right here is the same as the code that's embedded in the lesson right here. There's just a few extra comments in this version. So let's just go through this piece by piece. In this initial example, we're using a library called Axios. And if you've never heard of it, there's a link underneath the code example where you can read about Axios. This is a library for making promise-based queries in the web browser. Axios is a very, very popular library for everyone building applications in JavaScript and TypeScript. And so what we're showing you here is just a basic example of how to use it. I import Axios. I then create an Axios instance. I can call it whatever I want, right? In this case, I'm going to call it block frost, but I could call it, a lot of times in code, you'll see that people just call their Axios instance Axios, because that makes sense. But it's really important to recognize this name is just arbitrary. I can call it whatever I want. So I'm going to call my Axios instance block frost. And when I create it, I have to add a header with my block frost project ID. This project ID is saved as an environment variable in my project. And there's some notes about this down below. Let's skip to these notes, and then we'll go back to the example. If you've never used environment variables, you can look at an example in the repo. There's a .env.example file right here in the Plutus PBL 2024 front end. And this example shows that there are 2 keys you're going to have to use. You need a Maestro API key for the Maestro example to work. And you need a block frost project ID for the block frost example to work. And if you make a copy of this file with just the name .env, okay, just this part, you can create your own copy of this file, and then you can add your own API key and project ID. When you do, you will be able to run these queries locally. But without these keys, this app will not work on your computer. So I hope that part makes sense. Does anybody have any questions about what I'm showing you just at a high level about setting environment variables? Okay, this is a great thing to learn how to do. And I know that using kind of, setting up your own environment variables is often one of those hurdles that new devs have to jump through for the first time. Once you do it, you'll start to see that it makes a lot of sense. Okay, and if you've never done this before, I would love to help with this. And there's some other people on the Gimbalabs team who can help as well. So be sure to ask questions. Now, why doesn't my .env file show up in the Git repo? Okay, here's why. In the git ignore file, .git ignore, this shows us all of the files that we are not going to include in our Git repo. And you can see one of the files that does not get included is .env. So let me show you what this repo looks like in my VS Code. Here's VS Code. Nope. There's my browser again. Give me one more chance to do that. There it is. Okay. So here's this repo in VS Code. And you can see right here that I do have a .env file. I'm not going to show it to you because then there would be some private data published on YouTube. But in this file, I've made a copy of these two lines, and I've just replaced it with my own keys. So hopefully that makes some sense how this works. Once I do this, let's go back and look at that block frost query again. We can look at it from VS Code or the browser. I pull it in with this line right here. Okay, so process. This is built into how a Node.js project works. Okay, I can say process.env, and now my Node application knows that I'm pulling in a variable from my env file. And then I have a variable named this, right? We just saw it right here. Next, public blockfrost preprod project ID. It's exactly what I see here. Now, why do I have this next public part on it? As you might be aware, the application we're building right here, this PPBL 2024 front end, is a Next.js application. And it's not exactly best practice to use Next public environment variables, but I'm using them here just so you can get started quickly with prototyping and learning how to build a Cardano application. This is fine for the learning part of your journey, but when you're ready to go into production, I definitely recommend reading more about how environment variables work in Next.js. And that's why we're including this link right at the bottom of the lesson. You can learn more, right? And you can see right here, bundle environment variables for the browser by prefixing with Next public. That's where that's coming from. However, there are some risks to using this in terms of how your private API keys can be exposed to people who know what they're doing. Now, in the case of, my free tier, in this case, right, I have my own blockfrost project ID. But the worst thing that could happen if somebody got my project ID is they would be able to just use all my free blockfrost credits, right? I'm not too worried about somebody getting this. However, if I was paying a lot for a subscription and really wanted to make sure that I had a fully secure application, I would not use this approach. I would make sure to get rid of the next public part, and I would make sure to do a much better job obscuring my paid API key. Does anybody have any questions about that part? Sarah, what do you think? Oh, and if you're talking, you're muted.
Sorry about that. So when I moved my app from local development platform to Vercel, the blog post API key and other API key just was not working. I was getting all strings because I found out there's something called CORS, cross origin resource sharing.
Yes.
So yeah, so Nelson helped me out with that. So he sent me some useful links, and it was so maybe you can touch on that a little bit more. Thank you.
That's a really, really important concept. And what I'm trying to do in this lesson is give people just enough to get to the real goal, which is making our first block frost query. So I'm not going to take a detour into the details of how Vercel handles cores right now because it would probably take up the rest of our time today. Okay. But for now, you're exactly right. When it comes time to deploy your application on a service like Vercel, number one, you'll have to learn how to add those environment variables to the deployment. And there's documentation about that. And then depending on your use case and how your example works, you might have to set up some other variables so that your application can interact with some other API endpoints that you need it to interact with. That's always going to be a concern. And I'm really glad you're learning how to use Vercel and cores. But let's save that deeper concept for when we have a little bit more time. Is that okay?
Perfect.
All right. For now, I've already spent, I know I had to spend a lot of time just showing you the basics here of environment variables, but this is kind of giving you just enough so that you can start using things like Block Frost or Maestro in your own applications, and you can get it working locally. Let's look at a few other things in this example code. Right here, I actually need to define two types because this is a TypeScript file. And you might have noticed that in the repo, all of my component files end with this .tsx extension. If you've ever used React before, maybe you are familiar with .jsx extensions. What's the difference between JSX and TSX? Well, the J stands for JavaScript, where the T stands for TypeScript. And you have both options, but we are using TypeScript. And the reason we're using TypeScript is that it's a bit more reliable than using just plain old JavaScript. Using TypeScript takes a little bit more work initially because you have to make sure that all of your types are compatible throughout your application. When you use JavaScript, you don't have to worry about this. And that's why early on, JavaScript development moves, it feels like it moves faster than TypeScript development. The problem is when a bug emerges in your JavaScript application, sometimes it can be really hard to find that bug. And so even though we're spending a little bit more time up front by making sure that this is actually a fully compliant TypeScript component, we're saving ourselves time in the future because TypeScript makes it a lot easier to find and fix bugs in your application. And that's why right here, I define a couple of types. I need to define an asset type to represent the data that I'm going to pull in from my query. This query is going to give me a list of assets that have an asset string and a quantity string. I'm going to save them when I call set data down here, set data res.data. The result of this API call is going to have a data field in it with a list of assets. I make this response type so that I can have a compliant call right here to the endpoint itself. And this endpoint is going to return some data and a status code. It actually also returns some other helpful stuff, like a cursor, for example, just in case you have a large data set, right? But for now, here's a really nice thing about TypeScript. When I define a type, I'm able to create a type where I don't necessarily have to cover everything, but I can just define the parts of that type that I'm going to be using. Now, another reason I'm showing this to you right now, but not going fully deep into it, is that in the rest of the examples, we're not going to need this part anymore. And I'll show you why we don't need it in just a moment. But for this basic example, where I'm using plain old Axios all by itself, and I'm making this query and saving the data, I needed to create these types to have a compliant TypeScript component. All of my API call is in a use effect hook. A use effect hook allows me to build logic that will run in the user's browser, but maybe not right away, or maybe after something happens. So let's look at the structure of this use effect hook for just a second. What you can see right here is that this use effect hook is going to run every time the value of toggle fetch data changes. The way use effect works is when you load up a web page for the first time, the use effect hook will run for the first time. Then it will run again anytime the variables in this dependency list change. And if you've ever seen the code for like an advanced React application, you might be aware that there can be several different items in this list. For now, I just have one, toggle fetch data. What is toggle fetch data? It's defined up here. It's a use state hook that's just a Boolean. It can be true or false. And when the page loads, its initial value is false. Okay, that's very nice. So the first time the page loads, we try to run this hook. We define an asynchronous function right here, but then we say, hey, if toggle fetch data, in other words, if toggle fetch data is true, then run fetch data, run this async function that actually has the query. But if you're really thinking about this, you notice something important. When the page first loads, this is false. So the first time use effect runs, toggle fetch data is false, and therefore this if statement does not fire, and therefore fetch data does not run. And that's a good thing. I don't want to run this query every time somebody loads this page. I only want to run it after something else happens. Well, what's the something else that's going to happen? In this case, it's just the user presses the button. Look, I just reloaded the page. When the page loads, no data. But when I press the button, data, there it is. How does that work? Well, like you just saw, we need toggle fetch data to have its value changed for this use effect hook to run. And then we need that value to be true in order for us to actually fetch the data. So look down here. The component itself is very simple. It's only this is 10 lines of code, right? And 2 of them are just to wrap this thing in a div. Here's an H2. It says, here's an example of querying by policy ID. Let's just situate ourselves. That's this little headline right here. Here's an example of querying by policy ID. Then we have a button, and maybe we see a list of data. The button is right here. Button. Fetch a list of all PPBL 2024 token names. And what happens when this button is clicked? Ah, that's what onClick is for. Whenever this button is clicked, we're going to set toggle fetch data, right? Change the value of toggle fetch data from false to true. When I click the button, this value becomes true, which means the use effect hook fires because toggle fetch data has changed. And then it gets to this. Oh, wait, toggle fetch data is true now. Great. That means fetch the data. How does that feel? I'm going a little bit deeper into just some basics of building a UI with React. And I know that some people are already familiar with this, but if you're seeing this for the first time, do you have any questions to connect the dots here? Okay, so I click the button. Now it says true. Yes, let's fetch the data. So we do this, and then we set the data. Now look at this line right here. We have a use state hook called data, and its initial value is undefined. Undefined plays a similar role to false. And so if you've ever heard somebody say the word truthy or like truthiness, I'm going to write that word in the chat. Truthiness, kind of a funny word. Truthiness. Okay. The truthiness of a value depends on what data type you're looking at. So obviously for a Boolean, true is true and false is false. That one's easy. But for other stuff like numbers or strings or open-ended types like this one, undefined has a truth value of false. And hopefully that makes sense to you, right? If a value is undefined and I ask you, hey, is there any data, right? Data, question mark. We're saying, hey, is there any data here? This is going to be false if it's undefined, if we just loaded the page. And this is why when I first load this page right here, no data shows up, right? There is no data to show because we haven't run the query yet. So this question mark says, hey, if there is data, map over it. Map just means take a list and do a thing for every item in that list. Okay, great. Let's take our data, which we already know has the type asset type list, right? So we're mapping over a list of these things, these asset types that have an asset string and an asset quantity. So we say, okay, map over all of those. And we know that they have a type that includes an asset. So that's what we use. We say, okay, for each item in the list, look at the asset and do this. First, take the substring of that asset. And you can look this up on like Mozilla Docs, for example. Substring 56, what does it do? It just removes the first 56 characters in a string and returns the rest of the string. Why can I remove 56 characters? The reason is because the first 56 characters in an asset string are the policy ID of the token. It's actually this policy ID right here that's in my query. But I don't really care about that policy. I already know that my whole query is about getting all of the assets that have this policy ID. So in other words, these first 56 characters are going to be the same for all of these strings. Let me ignore them. How? By taking substring 56. Ignore the first 56 characters because I already know that's the policy ID. What I'm interested in is the name of each of these assets. Once I have that, the rest of that string, I use the mesh hex to string function to convert it from a hex string to the human readable strings you can see right here. So we went from an asset, we chopped off the policy ID, and then we converted the asset name into something that humans can read. Maybe some of that makes sense, and maybe not yet. So let me look at this a different way. I'm going to jump back to VS Code for just a moment, and you can do this on your own. And I recommend this. Let me go down here, and you can see line 51 is commented out. I'm gonna, whoops, what's the key? There we go. Okay, I'm gonna uncomment this line because I want this to show up on the screen. What is this? This says JSON.stringify. JSON.stringify, you can read the docs right here on my screen, right? This converts some JSON values into some data that I can actually just print to my screen. Okay. And as you're going to see in just a moment, all I'm doing is I'm taking the raw data of this response up here so that I can look at it. All right, I want to be able to read what's here. The pre-tag, right? This is an HTML tag that allows you to format like a monospaced font, which is kind of what people expect code to look like. So that's really helpful. I'm going to save this now that I've uncommented this file. And then in my terminal, make sure I'm using the right version of Node. And I'm going to run this locally, npm run dev. And now it's running at localhost 3000. Let's jump back and look at what we see on the screen now. You see, it's the same website, but it's my local version. I'm no longer at plutuspbl.io. I'm going to go over to the live examples. I'm going to open up example 204, and then I'm going to run this query again. And when I do, look at all the raw data that shows up. Ah, maybe it's nice to look at, but can you see how this is not as easy to read as this list right here? Because it's the raw results of my query. But just like I showed you, every one of these asset names starts with the same 56 characters. That's the policy ID. There it is. So hopefully you can see why I am cutting off the first 56 characters with substring 56. Then, even after I lop off those characters, the rest of the string isn't really helpful to me. I can't read that. So what do? I run hex to string, and I convert this hex string to the human readable string that looks like this. Does anybody have any questions about that? Okay. It always takes the most time to go through the first example. Let's see. I told you about Axios. We talked a little bit about API keys, and I'm going to leave it to you to learn how to get your own API key. Okay, so the step-by-step instructions are to try to run this locally, just like I showed you right here, where I'm running on localhost 3000. But the thing is, you won't be able to see these query results on your local, when you run this project locally without first getting your own API key and correctly placing it in your .env file. So that's the real task for you as a student right here, is to make sure you understand how to do this. I'm not going to teach you how to make a Blockfrost account because Blockfrost already does this. And I trust you to go read these docs, figure out how to sign up, make a new project, make sure the project is on Cardano pre-prod, and then get your Blockfrost project ID. Okay, so that's the exercise for students. Of course, if you get stuck, let us know. There's a lot of people at Gimbalabs who will be happy to help, but I bet you can figure this one out. Once you have your Blockfrost key, you'll follow through with those steps that I referenced earlier, creating your own .env file and placing your Blockfrost project ID right here. If you are successful, you'll be able to see what I see on this example. You'll see the response. And let me, off screen, I'm just going to get rid of this stringified JSON. Okay, look, so you'll see this, and this is how you'll know if you successfully set up your Blockfrost API key, is that this query will work when you run it locally. We talked about hex to string. That's good. We went through some details about how we're mapping over the data. And then, yeah, using hex to string, substring, etc. I think that's everything. All right, does anybody have questions before we move on from this example and we go look at Maestro? All right, let's keep going. So at the top of this lesson, I asked, did you notice how there are two tokens for each name? Yeah, we're going to talk about that now. Okay, so when people minted their PPBL 2024 token, you actually minted a pair of assets. And if you've been working through the course, you've already seen some of how this works. In lesson 203.3, right here, we showed you that what we're talking about are token pairs that implement some of the CIP68 standard. We're not implementing the whole thing, and I'm not going to go into the details of what we're not implementing right now. But we are playing with the essential idea that when you mint some dynamic token, like the PPBL 2024 token, one emerging standard is that you can prefix one of your tokens with 100 and the other one with 222. Then you can send the 222 token to somebody's wallet. And you can send the 100 token somewhere else. In this case, we're sending the 100 token to a validator address. And each of those 100 tokens is stored in its own unique UTXO at that validator address. And why is this interesting? Because in each of these UTXOs, we can also place some datum. And then we can use a smart contract to make sure that only the person who holds the 222 token can update that datum. And this was the assignment earlier in the course. In assignment 102, the title of the assignment was Change Your Lucky Number. When your token was minted, that lucky number was automatically set to 2024. In this lesson, I'm going to show you how to use a Maestro query to look at the on-chain data and find out how many students were able to complete this assignment. This is pretty cool. We're looking back at some of the results from earlier, and now we're going to find out what the blockchain says. Are people who mint tokens completing assignment 102? Let's take a look. Let's go look at the live example. So back to this page, where previously we looked at SLT 204.1. There's also right below that a demo for the lesson we're now looking at, 204.2, Maestro. And it works the same way. I can click the button, and when I do, it fires off the query. What we're looking at here is the datum that's on chain for each of the tokens that has been minted. And in this datum, this bit right here is where the lucky number goes. And if I look at this list, you can see that we're still just getting started with Plutus PBL, because as I scroll down, I can see that most people have not yet changed their lucky number. So here's the challenge to everybody, right? Oh, demo 3 did. Demo 3 changed their number to 28. 28 is one of those unusual perfect numbers. And if you don't know what I mean, just look up online, what's a perfect number? And that's a delightful little mathematical detour. But I digress. Let's keep scrolling. Who else has changed their lucky number? Love is Real changed their lucky number to good old 69,420. Very nice. My Token changed it to 2025. Shrey changed it, nice job, to 108. And for now, is that all? Yeah, okay, so we have 4 people so far who have minted a token and completed assignment 102. Obviously, we want to keep growing from there and make sure people are getting hands-on and accomplishing these things. But this is the data. And here's the on-chain data to show how far people are going. So how did we get this data? Well, we used a Maestro query. Here's the example code. And because I just took so long to go through the first example, we don't have to look at everything here. So for example, I'm not going to talk about using API keys again. This is coming from the same place as before. But I do want to highlight a few things that are different. One thing that's different is that instead of using Axios, we're now using something called Maestro Client. Instead of using the general purpose Axios library that can work for any sort of API call, we're using a Maestro client that is provided by the Maestro team in their TypeScript SDK. And if I look at the source code, I want to go back to the source for this project. I'm going to look at package.json just to show you that maestro.org TypeScript SDK is installed. And anybody can install this in any project by typing npm install and then this string right here. Now, this is a very, very nice tool because A, it allows me to focus on using just the Maestro part, and I can configure it very quickly. Okay, yeah, I've got my API key and I want to use it on the pre-prod network. If I ever go to mainnet, I could change this word to mainnet, and now I'll be using Maestro on mainnet. I set up the same hooks as before. We've got a data hook and we've got this toggle one, right? That triggers when I press the button. But this time the data type is UTXO with slot. Just like before, it's a list, right? We had a list of assets before. Now we have a list of UTXO with slot. But here's another difference from the previous example. This time I'm not defining the type myself. I'm importing it from somewhere else. And that's very convenient. If you're learning TypeScript development, you might be aware that defining your own types takes a lot of time. If you use a library like TypeScript SDK, now you're just reusing the work that the Maestro team has already done. And this is very nice down here because we're in the previous example. Let me just toggle back to that for a moment. In the previous example, I needed to know what type to expect from my Axios request. So I had to define this type right here. In the second example, I do not have to define the type of res because I'm using a Maestro client. I'm using addresses on this Maestro client and then UTXOs by address. And because I'm using this built-in method right here, this already knows what type res is going to be. What type is it going to be? Oh, it's going to be UTXO with slot. So using these third-party libraries can save me a lot of time when I'm building a TypeScript application. Does anybody have any questions about that?
Hey James, I have a question.
Yep.
I,
Hey,
I just
Stephen.
wanted to, hey, how's it going?
Yep.
I just wanted to, I guess, clarify. I haven't made it this far in the course yet, but essentially, Maestro and Block Frost do essentially the same thing, just different syntax.
Yeah, they are almost interchangeable with each other. And I say
Gotcha.
almost because I recommend playing with both. I
Okay.
think most people will have a preference, but I think preferences are split 50-50. You just have to find out which one you like better.
Okay. Thanks.
Yep. So we've got this. And what I'll show you in the next lesson is that mesh makes it even easier to switch back and forth. We'll get there in just a sec. The rest of this example, there's not much more to say because we covered it in the previous example. Okay. Down here, we're going to map over the results of our query. And this time, we're interested in a few things at once, both the name of the asset and the datum. So back here in the example, you can see right here that we've got the asset name, and you can see right here that we've got the datum. The asset name is coming from right here. This should look pretty familiar based on the prior example, but notice this time I'm not taking substring 56. I'm taking substring 62. In other words, I'm chopping 6 more characters off the front of that hex string. Why? Well, because the first 6 characters we're either going to be 100 or 222. Now, wait. You might be thinking, wait, 100 has 3 characters in it, not 6. You're right. But a hex digit takes 2 characters to represent a single character. Okay, so 100 is 3 digits for us, but it's actually a 6 character hex string. The number 100 in hex is 31 for 1, then 3030, right? 00. And 222 as a hex string is 323232. And you can see this by playing around with the queries. And I recommend you just get familiar with a little bit about some hex conversions because you'll find that you start to recognize a few patterns in there. Okay. So I'm chopping off those first 3 digits because I know they're going to be the same every time. And now I can just see the name of the token, the part that follows those 3-digit number. Then right here, the next bit is once I have that token name here, we're just going to JSON stringify the datum itself, the inline JSON part. Okay. Now, I'm not going to go too much deeper into this because just like with the block frost example, your task is to get this running locally, right? Try to run the thing locally by making sure that you make a Maestro account and you pull an API key into your .env file. You'll know you're successful if you can see the data on the screen when you're running locally. So my local example is still going. You can see I have it set up correctly because I have my .env file correctly configured. If you get stuck on this step, this is a great place to reach out for help. I'd love to make sure that you can do this, but I don't want to tell you too much more right now because I really want you to try this on your own. Okay. So that's the task. And once you have this running, once again, for example, you can uncomment this line to just see the raw data of the whole request. And if you do this, it's going to help you learn more about exactly what, in this case, Maestro is providing. Now, there are a bunch of other tools for looking at query results. I wouldn't recommend always relying on this method. I like to use this method sometimes just to make sure that my app is wired correctly. I might do this to say, okay, yeah. Is the data coming through properly? Yes, it is, right? But if you're just testing queries, there are other tools like Postman. I just said the word Postman. What's Postman? It's an API platform that just allows you to type in a query endpoint and look at the results without the need for any front end. And this is really helpful if you're just starting to understand how API queries work. So on your own time, you can explore this. And there's other competitors to Postman that do the same thing, just with slightly different features. So you can explore that. But for now, I think we've got enough. All right, so make sure you read about the TypeScript SDK and about Maestro. Now, I mentioned in the lesson here, there's actually not yet a lot of public documentation for Maestro's TypeScript SDK, and I'm not sure exactly what their plans are for providing that, but it's still awesome that they created this, and I'd like to show you briefly why. I'm going to jump back over to VS Code and I'm going to open, really I could do this from any file, but right here, this is the query token datum where we set up our Maestro client, right? Now here's what's amazing about an SDK like Maestro TypeScript SDK. I can create some new variable. I'll just call it X. And then I can say X is a Maestro something. And when I press dot, look at the magic. Oh, I spelled it wrong, so it didn't work. Let's try this again. And there we go. Now it's spelled correctly. And if I press dot, look at this amazing thing that happens. Autocomplete pops up. What can a Maestro client do? All of these things. And if you've ever been looking for a little rabbit hole to go down on your own, here's one. Just play. See what you can do. Get your Maestro API key, pull in the Maestro TypeScript SDK, set up your Maestro client like this, and then just explore. Maestro can do stuff with transactions. Cool. What can it do with transactions? Dot autocomplete. All right, it can tell me the transaction CBOR, the transaction info, the transaction out by TXO ref, and so on and so forth, right? And you can just see what each of these things does. We were just using addresses down here, UTXOs by address. And that's one of the options in this list. Cool. But what if I wanted to see, ooh, what about just transactions? Could I do that? I sure could. All right. And now I can also look at the type of this thing. There's a few ways to do this. One is to mouse over it and see what the documentation says. But also I can right click on a method like this, and then I can click on go to definition. And this opens up the source code for this method in my node modules directory, right? So the Maestro TypeScript SDK, when I run npm install, all of this code, look, thousands of lines of code are just pulled into my node modules directory. Nice. And I don't have to write all these lines of code because now they're already here. And I can just use them by doing what I showed you right here. But remember, at any time, I can go to definition. And this, in my opinion, is even better than the documentation they could publish online. Okay. So yeah, at this moment, Maestro TypeScript SDK, I couldn't find public docs for it. If
Yeah.
you can, great, let's look at that. But it's
So
already right here built in.
can you hear me?
Nelson, yeah, I can hear you're very soft.
Oh, am I audible now?
Yeah, got you.
Yeah, so yeah, I don't think there will be any more documentation as the SDK because it is structured the same way as the API documentation. So you
Perfect.
can see the API Maestro docs and the SDK just follows that pattern in the same manner.
Nice. Okay. So right, there's not even a need for this. And that's one of the notes we have here too. So jumping back to the lesson, um, whether you're right or not, I agree with you. Like, right, like we've already got these docs. And so UTXO is by address, that's the name of the method. And like Nelson just said, you can look at the documentation for this directly. Anybody else have questions about that? Okay. So play with this, and I hope you have a good time. As always, questions, you can bring them to Gimbalabs Discord, you can bring them to these live coding sessions, or you can chat about it right here, right on the lesson page. So, pulling it all together, and we're over time, so I'm only going to spend 2 minutes talking about this right now. Once you understand queries in the basic way I just showed you how to, for example, you could use Axios, and you could use Axios with Maestro as well, right? I'm showing you Axios with Block Frost, Maestro with some of their built-in features. These are really nice, and in the long run, you might actually prefer to have the flexibility of Axios, for example. But you don't have to learn that because Mesh makes it even easier. And so I hope you'll read this lesson to learn about Mesh providers. Mesh has providers for Block Frost, Koios, Maestro, Agmios, and Yahtzee. Koios does similar things to what Block Frost and Maestro do. Agmios is a little bit different, and it's beyond the scope of what I can cover in 2 minutes. So we're going to pin that for a later date. And Yahtzee allows you to set up your own side chains and test networks to make it even easier to build. And I do recommend learning about that as well. But what you'll find in this lesson is that there are two examples that are exactly the same as what we just covered. I'm jumping back to VS Code. I'm going to open up the same queries directory that we've been looking at, queries for Block Frost and for Maestro. And right here, you'll see that for each of these, there's a mesh version of the same exact query. The results on the page are exactly the same, but the query is different. The code is a little bit more succinct. Okay, you'll see that I need less lines of code to get this working like this, but then I can use some built-in functions from Mesh, and that's very convenient. We're going to cover this more next week if people have questions, and we'll also be ready to move on to module 205 by then. But I hope this is enough to get you started. We didn't have time to cover the why do indexers exist example, so we'll cover that in an upcoming lesson. But for now, I hope that this gives you enough to get started, to accompany those first two lessons, and we'll keep building from here. Anybody have questions before we close out for today? All right. It's always hard to know. This doesn't feel as interactive as I want it to be, but thanks for listening to everything I just shared, and I hope it's helpful. And do be in touch as you start jumping into these lessons. Thanks, everybody.
Thanks, James.
See y'all soon. We will be, for anybody watching this recording, we meet like this on Wednesdays at 14:30 UTC. You can find a link to this meeting at gimbalabs.com/calendar. And then we meet on Thursdays at the same time, 14:30 UTC, to talk about governance and project planning at Gimbalabs. So tomorrow's meeting on the 3rd of October, 2024 is going to be a good one because we've got some plans around Catalyst Fund 13 to figure out, and we have a couple of really good proposals in the backlog to look at. So looking forward to that. If you're there, see you there. Otherwise, see you soon. Thanks, everybody.